Finally tonight here, this question. Does a year in space really change you?
The hypothesis of Albert Einstein shows that items look progressively mutilated as the speed of movement increases, with the view ahead turning out to be continuously more splendid. Then, genuinely unusual impacts begin to kick in, with objects a long ways ahead obviously moving further away. While those behind materialize. In view of this hypothesis, it was reasoned that the speed of light is steady and stays free of the spectator. In this way, on the off chance that an individual goes at a portion of the speed of light in a similar heading as light, the light pillar will seem equivalent to it does to a fixed person. At the end of the day, the speed of light remains consistent, whether or not the eyewitness is fixed or moving. Einstein's hypothesis of unique relativity shows that as an article with mass draws nearer to the speed of light, the mass begins to increment as it approaches the speed of light, Pravika said. In the event that an article could arrive at the speed of light, it would turn out to be vastly monstrous and would require limitless energy to keep up with that speed. On the off chance that you could go at the speed of light, items wouldn't cruise by. They proved unable. Thus, you're as of now, wherever in the universe, immediately as the whole universe has fallen down to a plane of endless slimness. Moreover, when you had the option to deal with a solitary idea, the universe would have met its possible end, as time is elapsing by vastly quick. So you get rolling at light speed, wanting to get to the following star framework in a sensible measure of time, and the whole universe goes poof. Time and space can't stand it when enormous elements go at light speed, such a lot that they, in a real sense, twist to forestall it. Presently, on the off chance that you didn't really go to light speed, yet a hair under, say, 4999c, then you'd see the stars, compacted almost level, zooming past. In your spaceship, your eyes actually see noticeable light. However, as far as you might be concerned, that is microwave and infrared emanations as you approach and X-beams as you cruise by. So earthy-coloured small stars will be sensibly splendid as you come dependent upon them, then, at that point, vanish as you pass. On the off chance that your speed expands, there is length constriction and time widening. On the off chance that you travel at 90% speed of light for a very long time. As indicated by us, you have gone for a very long time. Accordingly, you will be 5 years more youthful than your twin after the excursion. You won't see anything peculiar during your excursion. In the event that you look at your watch while voyaging, you find it ticking with ordinary speed. Time enlargement returns to Einstein's hypothesis of unique relativity, which instructs us that movement through space really makes modifications in the progression of time. Consequently, the quicker you travel through the three aspects that characterize actual space, the more leisurely you're traveling through the final aspect, time, basically comparative with another item. Time is estimated distinctively for the twin who traveled through space and the twin who remained on the planet. The clock moving will tick more leisurely than the timekeepers we're watching on the planet. Assuming you're ready to go close to the speed of light, the impacts are considerably more articulated. There is no such thing as time at the speed of light. Thus, on the off chance that you could go at the speed of light, as far as you might be concerned, you were unable to do it for one day since there would be no section of time. Be that as it may, to somebody who didn't advance rapidly to the speed of light, you would return in 2 days. Nonetheless, regarding the spectators on the planet, the watch is ticking gradually. Concerning you, the watch on Earth will tick gradually on the grounds that, indeed, they're additionally voyaging away from you at TC as seen from your casing of reference. Yet again, and as per you, the twin very still is aging significantly rapidly as you approach the twin to come to a similar edge of reference. Likewise, as you approach the speed of light, this impact turns out to be considerably more apparent. You have quite recently gone for 1 sec at 99.9999% the speed of light, as per you. Yet when you return, millennia have passed on the planet. Note, this must be checked when you return to the Earth, subsequently making the casing of reference of Earth yours once more. At close to light speed, we'd scarcely perceive natural environmental factors. Moreover, the Doppler impact would make protests so splendid, we were unable to remember anything at all. As you arrive at higher paces, things begin to get peculiar. Heading out at extremely near the speed of light would appear as though complete obscurity, with the exception of a very brilliant spot, adequately splendid to kill you, toward the path where you travel. With this, humankind will always be unable to go at the speed of light. All things considered, we could hypothetically draw near. To create the least issues for our human tenants, ideally, let's keep up with the speed increase our body knows about the world's gravitational draw. Nonetheless, because of the huge speed, you would encounter critical relativistic impacts. For example, length constriction and a change in the shades of items because of the Doppler impact. It's critical to take note that this is all hypothetical, as right now, it isn't feasible for anything with mass to go at the speed of light. In this way, objects with mass can't at any point arrive at the speed of light. Assuming that an article could possibly arrive at the speed of light, its mass would become endless. Furthermore, thus, the energy expected to move the article would likewise become boundless, an impossibility. The just thing moving at the speed of light will be light itself. Photons don't convey light, they are light. So, an approaching photon at US will set off a reaction. The arrival of intensity can really block an item's capacity to arrive at the speed of light. As an article's dynamic energy builds, it will likewise create heat, speed. A lot of speed increase in motion can damage, and even kill us. So what do you think? Would you like to give it a try someday? Please drop a comment on the comment section. And if you enjoyed today's video, kindly like, share and subscribe. Thank you for watching. Yes.